Let's continue to finish the table review we left out from the first video. Now, I'm sorry I tried to keep the video only 15 minutes. So I think that's the best time, not too long, not too short. So yeah, they also will cut out for the 15 minutes. Okay, let's continue. So in the previous video, we end with how many students we want to know they sleep over 8 hours. So the first one we show you, right, you can do the original table, okay? So we see where the label name is hour of sleep. So we're using the art above or equal to 8. So from here, they will show all the row for the sleep over 8 hours. So do the dot number of row, you can see the result. But also on the other hand, we can use the column function as well. So if you use the column function different from the where, they return an array. Okay, so that's why we see the array. So if you have this array return the hour sleep, so we add a condition greater or equal to 8. They will see each element, are they greater or equal to 8? They display true or false. So the true in Python represent 1, false is 0. So on the other hand, we can also see after this array, we can see how many non-zero, because we want over 8 hours sleep, we want to see the true. So any non-zero number, that means that's true. So we can do here, since we have the array, so we apply the numpy function. They have one count, non-zero. So then you can see here, they will return 473 as well. So either this way, true and false, false represents 0. So then we can do the non-zero, that means true. Or you can see, since true is 1, so also we can do the sum for this array. Again, the true and false, the Boolean array, we're using the numpy sum. Then they will give you all the true. 1 mean how many 1 there. Okay, so that's 3 different ways you can find how many students sleep over 8 hours. So this section of your Jubic notebook document, basically we review how we all the table method we introduce you. So here we just want to show you another one. If you want to work on your table but just want to choose specific column to create a new table, yeah, we can do that as well, right? You're just using the select. Okay, so using the select, you just pass in the index of the column or the label of the column. So here we only have the hour of sleep and hour and sleep position. So then we create a 2-column table. Okay. Oh yeah, you need to display. Okay, so then if we display, so that's you only have the 2-column table. So if you don't like the label, you can rename your label. Okay, so here we just make the hour of sleep 0. So then we make the hour sleep, that's the index. You see that we say you can use the index or using the label. We just change to hours. Then the position, we just change to sleep position, we just change to position. Okay, so then you will see here, you create a new table. So after you create a new table, don't forget you need to assign to a new name. So this one will equivalent to you select only 2 columns or you just drop all other columns. So these two, you will get the same exactly result. But which one you prefer? Yeah, because we only need 2 columns, I will prefer this one. Yeah, instead you drop the rest of the 6 columns. Okay, so that's our table review. So now let's do the next topic. We will introduce you the census data. So what is the census data? Actually, every 10 years, in U.S. Census Bureau, they will see how many people in the U.S. So that's every 10 years, we will get the census data surveyed in mail, so you just return. So we only do every 10 years to get some population information. So also the survey, they including a lot of questions. So that's why later the data we will analyze, we only focus on the age and the sex. So here in the survey, they have a lot of questions, but only do once 10 years. So then you will say, how about they're still using the data for every year, right? So how can you get it every year? So they only do the big survey 10 years. So in between, they're using the estimation value. Okay, so they kind of, maybe they do the linear regression or something. So then all the, only do the survey every 10 years, but in between the data, they're using the estimation data. Okay, so here the census table, if we want to see, of course, they have much bigger data. So the one we use here, we only have the 2 column. We have the sex column and the age column. So the sex column, 1 represent male, 2 represent female. Yeah, I know we only have 2 categories. Maybe it's not up to date, but we will discuss this issue later. So then you also have the row is called age. Okay, so actually each row, they just show you on the 0 represent, male represent 1. 1 is male, 2 is female. So then the age start from 0 to 100. Okay, so then you have 0 to 100. But of course you will say, how about over 100? Okay, over 100, they're using the 999 for the total for the all ages. Okay, so then the other one, they also will have the sex column. They also show you the total. So even we only have the categories male 1, female 2. So then 0 actually just mean the total. So then we have sex column, age column, then we have the every estimation year of the population. Okay, so then you will see the so here you can see the more information, but then we will show you the data when we do the Jupyter notebook. So remember, all the columns should have the same type. So numeric code usually we using for the for storage efficiency. For example, you say instead you do the male, female in that sex column. You know, you search by the string or do the calculation or some manipulation for the string will not easy. So sometimes a lot of time if you only have few category, so then we just using the number. Okay, so let's see the census data. Yeah, so we have 2019 census data in the CSV file. So we see how they look like. Okay, so here we have the 4 census data. Like earlier we said, you have the sex column, you have the age column. So then you have all the population. Only 2010 is, you see here is no estimation. So the 2010 is one survey we have. Okay, so then you can see all the rest of that, they're just using the estimation to estimate after 2011 to 2019. Okay, so by default, you see here, if you just display the table, they only show you the first 10. So actually they omit over almost 300 rows. So if you really want to see the whole table to help you understand better, you do show. Okay. So then they will display the whole thing from beginning to the end. So this one is earlier we say the sex 0 represent total, right? Okay. I will show you later. Okay, so that's why here for the sex 0, age 0, so we can see 2010, that's the how many infants are now according to the sex. Okay, so then if you see the age, so at the end you will see here. So then they actually only 100, I think, represent over, including the 100, over 100. So then if age equal to 999, that's the total for that age. Okay. Yeah, it's a lot of data, right? So that's why we don't want to have the whole thing. So just focus on something we are interested in. We just try to get. So here, that's get. Of course, we have sex column and age column for different year. That's get the year for 2014 and 2019 only. Okay, again, you can just do here. We show 10 by default. Okay, or you want to specify how many line you want, how many row you want to show. Okay, so that's the data we get. You have 2014. You see, that's why it's difficult to type. You have population estimation. So then in order to do more operation easier, so maybe we can relabel on here just become 2014 and 2019. So we change to the US population. Okay, so then from the partial table we already have. So we relabel on the index 2014 is 2. So we change to 2014. Then the next one we change to 2019. Okay, so that's easier to show. Okay. So after we get that, of course, if you want, we can maybe just show the age over 80. Okay, so that's show only the age over 80. Okay, so then you will see here that's all the sex, so the age, so from 80 and above. So if you want to show everything, yeah, we can do show. Okay, so that's how you can see all the age above 80. Okay. So then you can see age 999 actually just mean the whole thing. Okay, so then you can see then just the male for the age over 80 and in 2019 and 2014. So that's all the data over age 80. So if you want, actually, yeah, you can sort, right? So if we want to sort, okay, so maybe we sort according to 2014. Okay, so then we will see which one has the most people. Okay, so actually, like we say, they by default is ascending order. So that's why here you can see, oh, yeah. So yeah, the age 99 for the male will be the most less. Yeah. Okay, so then you can see, yeah, just depends on what you want to sort, then you can display the result. So we will do more in the next video. But by the end of this video, I just want to talk about earlier, like we say, the sex column. The sex column, they only have code male or female. That thinks, the question actually thinks 1790. So at that time, right, that's their choice, right? They only have male and female. So you have to choose one. So you have no other option. But you know, the new days, sex categorization is more complex. So historical form, the question may not, so people doesn't know, some people they not know how they should choose the male or female. If they don't, then it will cost no response or inaccurate response. So one thing we need to know when we do the survey, we want to get the sample data. We need to design our question is suitable for the people to answer or our sample. Otherwise, you will cost, they see the question, they don't know how to answer, then they choose not response, or you got an inaccurate response. So this can make census data hard to interpret and use in the future. So we need to use the census data, keep those things in mind. So always when we design the survey questionnaire, we need to make sure that's fit, it's really suitable, and don't cause any bias.